Good afternoon, ladies and gentlemen. We'll begin the panel session now. I'd like to start off just by introducing to you the panel we're going to have on creating long-term sustainable partnerships in clean energy technologies. And to do this, I'm going to introduce each of our panelists first, and then go through a series of questions with them until we come to the end, and then we'll go through a separate discussion with one of our panelists, as I'll tell you about as we introduce this. So the context for our panel today follows on some of the very important developments that have happened most recently in the discussions around climate change. As we know, there is an ambition to mitigate greenhouse gas emissions to the extent that we don't exceed a level of carbon dioxide in the atmosphere that takes us to a level greater than 2 degrees Celsius in the long term in global temperatures. In order to do that, we need to achieve a certain level of ambition in sustainable energy technologies. And these technologies, of course, need to be developed in a way that is going to allow them to come to market from the academic labs and other research labs. This ambition can be challenging because we know going through the innovation life cycle, we need to turn those knowledge and technologies coming out of the academic labs and the research labs into innovations which have commercial value. And so in order to do this, we need to find the partnerships in which we can achieve these sustainable energy technology innovations and have them achieve the outcomes that we need to see happening in order to meet the ambitions that we have within this global community that's looking to mitigate greenhouse gas emissions. So with that as the background, we have a number of panelists today that are spanning the entire innovation life cycle, starting from the academic research institutions, going into research consortia, into venture capital and the industry as well. And then we have a separate perspective which is going to wrap all this together. The panelists today joining me are Dr. Linda Zhao, a professor of chemical and environmental engineering at the Master Institute of Science and Technology, Dr. Andre Fage, academic director of the Energy Academy Europe. We have Dr. Alejandro Rios-Galvin, who is actually seated here next to Linda, who's the director of the Sustainable Bioenergy Research Consortium and professor of practice at Master Institute of Science and Technology. Mr. Anup Jacob, who is a partner at Masdar Capital, and Mr. John Webley, who is founder, chairman, and CEO of Trevi Systems, which is actually a water company which we include under the broader umbrella of sustainability. On the end, last but not least, and very importantly, is Dr. Suji Nakamura, who is a professor of materials at the University of California, Santa Barbara, and also the 2014 Nobel Prize winner in physics for his co-discovery of the blue light-emitting diode. And most recently, in 2015, they awarded the Global Energy Prize for his contribution in the discovery of certainly the blue LED contributing to the white LED, which he'll be talking about further. Because we want to get the holistic wrap-up perspective from Dr. Nakamura, he will not be in the first set of questions. We're actually going to get the perspectives of our different panelists. And then Dr. Nakamura and I will have a discussion at the end, which really brings his story together about how you take a clean energy technology, which requires substantial investment, understanding of what it is to look at the basic science and move that forward to commercial innovation, and ultimately realize a startup company, which goes against the grain of a current technology in his space, the sustainable lighting or the LED space, and do something which is considered quite different from the norm. So that should be a nice wrap-up. So with that background, I'm going to start to talk to each of the panelists with specific questions for each of them. Then they'll respond, and then we'll continue down the chain. So I'm going to start off with Professor Linda Zhao, Master Institute of Science and Technology. And so Linda, the question we have for you is, as an academic, as a researcher, it's very common to be very focused on publications, trying to increase the amount of knowledge in your field. But really, when we look at innovation, the need is to partner with industry, understand industry needs, and to address those. So as from your perspective, knowing that you've worked with several companies now and trying to help them overcome their challenges, what has incentivized you to work with companies rather than just be an academic in the sense of publishing papers and just focusing on knowledge creation?
Okay. Good afternoon, everyone. My view is to conduct research in a closed lab, blue sky type of research is no longer the only model, but instead, the modern research take an approach which is more relevant to the industry and users. So as an academic or faculty, which are from a different background of the commercial companies. So we have the chance to still be driven by the discovery and problem solving, at the same time to do some relevant research with can make the life better and the world better. Apart from this, there will be other things which, for example, publishing, which Steve just mentioned. Publishing, my view, is still a very important part of the academic life, because the readers not only come from the research communities, at the same time, the industries who is looking for innovations will also looking for what are the current progress in innovation. So it can be a very powerful tool, marketing tool, to connect the faculty skills with the industry. So I think it should be a balance between the blue sky, closed, relevant research and a publication.
Thank you, Linda. So Alejandro, moving on to you, also working in the academic realm, you are the director of the Sustainable Bioenergy Research Consortium, which brings together a number of companies to focus on one particularly challenging problem in sustainability, which is creating low-carbon aviation fuels. So can you tell us from your perspective, what is the value of such a consortium in overcoming a very challenging technological hurdle, such as creating these sustainable aviation fuels?
Sure. Thank you for the invitation to be here, and good afternoon to all of you. The Sustainable Bioenergy Research Consortium has as its members the Masdar Institute of Sciences and Technology, who established the SBRC, together with Etihad Airways, the Boeing company, Honeywell company called United Oil Products, French-European conglomerate Safran, General Electric, and most recently we incorporated Takrir, who is the Abu Dhabi refining company. So this type of consortium allows for in the specific case that we are addressing, which is low carbon aviation fuel, allows for the integration of the entire supply chain, from the creation of the biomass that we need to produce the raw material, through the refining steps that will allow to produce the alternative fuel, and into the final client who will be using the fuel. And so all of the different players, or all of the different consortium partners, are interested in a specific piece of the supply chain. And so they bring value and they bring their knowledge as well to help the consortium through the different stages to bring from an idea to a proof of concept and then on to commercialization. So I think that the idea of creating these consortiums where the academic sector is involved together with industry partners that cover or span the entire value chain is a very important idea. Thank you very much.
So Andre, you've heard a bit about an academic perspective working with industry. We've heard from Alejandro about his directorship of this consortium. In your Energy Academy Europe, you're actually structured a little differently from other organizations we've seen, because you're encompassing a large component of this spectrum where we have educational activities, innovation-oriented activities, incubating organizations which could potentially contribute to sustainable clean energy. How is that organization of yours structured in the unique way it is, and what contributions is it providing under that structure?
Right. Thank you for the question and also for being here. Yeah, indeed, the Energy Academy initiative, as I like to call it, is a very young initiative. And it is set up in a philosophy, you can almost say it's European jargon, to work within the knowledge triangle: education, research, and entrepreneurship combined. And it is in that combination of activities that most progress is usually made. And what is done under that umbrella of the Energy Academy initiative is that knowledge institutions, so it's an entire university with energy activities across the board, from natural science to social science, applied research and education, vocational education, so the technicians that are needed in these new energy sectors, post-academic education, but also support of startups. This can be brilliant students or PhDs that come out of these programs, have ideas, and that want to start a new business. But this is, of course, difficult. So these things are combined in different programs. There are real new facilities, so test grounds, physical test grounds, but also organizational models. So how do you help a startup? Well, of course you need funds, but you also need networks. A new company needs launching customers, so we don't only do that in the Netherlands, but we link that to the European arena. Those customers could be all over the place. And it is in this interaction that we hope, with heavy involvement from the energy sector, that you can respond to these ever-changing questions and challenges of this energy transition that's happening right now. From the Dutch perspective, it's a small country, but if you zoom out a little bit and look at the North Sea, you could call this the biggest living lab in energy transition in the world, because it has a fossil energy industry that's on rapid decline. Oil and gas is declining fast. And at the same time, that's combined with massive investment in wind offshore, grid interconnectors. There's new options in sight, like wave energy. Macroalgae is being experimented with. So this entire energy system is changing. It means new business models. It means new infrastructure. And it is in that changing environment that new business is popping up, old business is probably losing here and there, where new professionals are needed and where government also needs to respond and facilitate. So we have, in that sense, a philosophy to put those players together in a lasting knowledge infrastructure and keep working on this along the way.
It's very interesting. It's a very interesting model, and so we'll be coming back to some more questions about that shortly. I'm going to move on to Anup. Mr. Anup Jacob is a partner at Masdar Capital. And so Anup, clearly you've seen a number of organizations which need financing to achieve commercialization of their technologies. But in the clean tech space, taking early stage technologies to the marketplace can be very challenging for financing. And so I wanted to get your idea about what gaps currently exist in this particular arena and what can be done to fill those gaps so that we see these sustainable energy technologies gaining traction in the market increasingly.
You know, Steve gave us these questions beforehand, and I've still been struggling to think through what the right answer is. So I'll attempt to maybe frame how I think about the answer. So Cambridge Associates looked backwards from 1982 to today for every single investment that's been done in and around clean energy. And what they found, and it's publicly available data on Cambridge Associates' website, what they found is that net, it's about a 1.2x return, 7% IRR. And this is across project finance through venture capital. And that ended up being one of the lowest performing asset classes that you would find out there. So earlier today in one of the panels, the CEO of SkyPower said, I think very correctly, the big elephant in the room is that capital is not flowing into this sector fast enough. We have the technology, you have the political will, you have the overall view from corporates that this is the right thing to do. So why isn't this just taking off? You know, why hasn't the golden moment been there? Why don't we have the Google of clean tech? And I think it's fundamentally that people's view of history is that it is a predictor of the future. And if I was looking at the future and saying, do I want a 7% return, 1.2x cash on cash, compared to investing into tech, telecom, et cetera, it's not that attractive. So I think that one of the areas that the gap that we're trying to fill in by having a specialized focus in this area, attracting institutional capital, which I think is fundamentally what you need in this area, is to show that you have de-risked the investment. So how do you de-risk the investment? There's three ways you do it. One is the provability of the technology, meaning that you have to have pilots, scale-ups, et cetera. The second is partnerships. We need the guys like GEs and Statoils of the world to put their stamp of approval saying we have partnered with these guys are real. And the third is that you need access to the debt capital markets. If you look backwards again over the past 50 years of how IPPs were built, it was built because fundamentally the debt financing market said that the PPA model works and that the PPA model is bankable and that you could bank it with 75 to 95% debt to equity. Until you get the banks to understand that the PPAs that you're signing up in solar or water or energy efficiency are as bankable as you would in natural gas or coal, I don't think you're going to get there.
Very interesting. No, it's I can realize that the question we give you is probably one of the most challenging. That's why we gave it to you in advance, so that you had a chance to think about that answer, which was very good, by the way, so appreciate that. So John, you are in also the clean energy space, or the clean sustainable energy, the sustainability space, called the clean tech space. You have a small company, growing company, Trevi Systems, working on forward osmosis. And we wanted to understand from your perspective, as you move your organization now from a early stage technology into the demonstration such as you're doing under the Masdar Renewable Power Desalination Program, showcasing how your technology can actually work at a scale that matters. What are the kind of challenges you're facing? What kind of partnerships did you need to build in order to move to this point in the evolution of Trevi Systems?
Thanks, Steve. Thanks, everybody. It's an interesting story. From the very beginning, Trevi engaged with a number of universities. And so it's interesting to look back on which ones worked and which ones didn't work. I mean, we partnered with UCLA, University of Illinois, Lehigh, Connecticut, and with the Masdar Institute. And, you know, there's a bit of a cross-purpose there. For us in industry, we need to get to market fast because our cash is king. And when it runs out, we die. So for us, there's a pressure to move quickly, and there's also a pressure to keep what we're doing fairly secretive because we don't want anybody else to know what we're doing. But we have to partner with the universities because they have the key information we need. But they want to publish, so that's the first stressor right there. We don't want them to publish, and they have to publish. The second one is we want to move really fast, and they want to understand everything about the problem and lay it all out. So that, ultimately, I think the answer comes down to why do certain ones work and certain ones don't. It becomes down to the willingness of the team at the university side to either take a year sabbatical and join us, and I've had that done a couple of times, where I asked the professor to come into the team because then we can run fast and he's not tied back to students and tied back to all the slowness of the academia. Plus, I get him to stop publishing. And then the second thing that happens, the second one that really helps is we try and lock these guys down with patents as fast as we can that belong to us and don't get published in the public domain. Now, some of the recent trends that upset me and actually worry me a lot are a lot of universities are so cash-strapped that they don't have the money to file for patents. And so they publish, and then nothing's protected. Now, try to get that funded by investors. That's even tougher. But for example, with the Masdar Institute, where we did partner, and we really had a great working relationship with the professor there, and he really pushed his students, that one actually worked. And of all the universities I've worked with, that one worked the best, which is surprising, because a lot of the US universities, the professors are way too busy, they have too many things going on, and they have way too many students. And so you don't get their time or their attention. And all they want to do is put out papers. And I understand that stress, but it doesn't work for us.
That's great. No, that's good news. So, of course, when someone says something nice about Masdar Institute, we appreciate that. So that was a very good answer, particularly good. Now, coming back to Linda, I'm going to ask you the question that I think is going to feed right off of John. What's the challenge of working with industry, given that you're working with these companies like Trevi, in your case, it's not Trevi itself, but what do you find to be the challenges as a faculty member in trying to build these partnerships which move their technologies forward?
There's several challenges, in my view, is like scale, time, and possible missing link. So one by one, the faculties at university works at a different scale because most of the research and discoveries was done in a much smaller scale in a laboratory environment. And this, if we're subject to the industry application, then it will be much bigger scale. And when you upgrade a smaller scale results into a much larger scale, you potentially feel a lot of uncertainties, whether the results still can be delivered, and how about the cost effectiveness, etc. So that's the first challenge. Second challenge is time. Apart from the publication, which John already mentioned, time means industry works in a much shorter time scale, mostly a few months. But the university often revolved around graduate students' programs, which last several years. So there is a mismatch there. But how to solve this problem probably need to fully communicate and knowing the expectations, so can deliver complementary results. The third one is how to let the industry know what sort of skills and results which are out there discovered by the university faculties, and this is not an easy task. For example, I really think that there's no simple answer. It can be improved by multiple combinations, such like university-supported marketings, medias, and alumni networks, etc. Of course, for example, the desalination, novel technology in desalination, if it's very sensible to be to be developed, designed, and fabricated, finally applied in Middle East countries such as UAE, because this is where the market is. So we still have a lot of chance to work with industry and make it through. Thank you.
Good. Of course, it takes good industrial partners to recognize the faculty have these perspectives and then appreciate those to make the partnership work. Alejandro, we're going to come back to you now. And with the Bioenergy Consortium, it's a very challenging topic we spoke about previously in which you're trying to tackle. And so the question that we'd like to understand is, what, as a consortium that you're directing with your members bringing their inputs, what particular approaches are you taking to try to get the highest probability of success in achieving commercialization of this integrated seawater energy agricultural system, which of course is what's creating this sustainable aviation jet fuel, drop-in fuel as one product?
I think that Anoop clearly pointed out this specific issue, which is risk reduction. What you are trying to do is make sure that you understand the technical complexities of what you're trying to do, so that whenever you're moving towards commercialization, you are able to have those proof of concepts with the confidence that you need. So for certain, one of the biggest challenges is to make sure that you understand the science and that the science is sound, and that in a different way that you're able to scale from that lab scale and from that idea into more of a reality. And so that's one of the biggest challenges that we are facing. And so we go and we implement a larger scale. And so we are now moving, for example, in our seawater energy and agriculture system, we're now moving to a pilot scale or a research facility scale, where we are implementing this concept from an idea into a 2-hectare facility where we have a small set of aquaculture ponds, a small set of fields where we will be doing halophyte agriculture, a few swamps where we will be growing mangroves. And so we have a real scale facility where we will be understanding those risks and working through them. The expertise from the different partners are also there, and they bring their weight into that operation of the facility, and they have different experiences from what they do in their industries, and so it creates a very interesting mix of input into how the facility is designed, into how the facility is going to be operated.
Just a quick follow on that. I know that you've structured your partnership to be, it's a very good partnership because you have, I believe, the entire value chain for your bioenergy, the product that you're trying to produce is one of the outputs. How have you considered the importance of having each of the different segments of the value chain represented in your board? Do you see that as a critical element that needs to be there in order to make this kind of endeavor succeed?
I think there's no question that you do need to have representation in order for us to be able to build a proof of concept for what we are doing. And the proof of concept would be creating 1 liter of aviation fuel from this halophytic biomass. And so in order for us to be able to do that, we need each and every piece of the supply chain to be there. So we've actually been very lucky to have all of the different partners in that space, covering each of those spaces, to come and join the consortium and give their input and work with us so that we are able to have that proof of concept at the end of the day.
Thank you. That's very important. Now, Andre, Alejandro has been talking about this consortium, which is a bunch of large industry players coming together to try and meet one of their challenges. And your structure with what you're doing with trying to achieve commercialization in sustainable technologies. You're helping startup companies, and you're trying to find ways to help them succeed. Can you explain how you and the Energy Academy are trying to support the development of startup companies so they can succeed in the clean tech space? What kind of things are you doing with these companies?
Right. Yeah, it also comes a bit with the philosophy of that those startups have to be part of a total innovation system, if you want to call it a bit broadly. But that means that you need the right conditions for those young people. So they sometimes need research support. They can be brilliant themselves. They may need business support. They can really benefit from experienced people from other companies that sometimes partner with them. What I already mentioned earlier, launching customers for their products. That's something that can sometimes be difficult to arrange, where help is sometimes very useful. So it's this kind of mixture of conditions that can bring startups more successful or increase the success rate of bringing startups to the market. I think it doesn't stop there also, because you can create all kinds of new companies, but in the energy field, and it was already mentioned, you're usually talking about quite long trajectories to bring innovations to a larger sector, and then, for example, to more competitive biorefining or a more competitive wind sector. So that is not a matter of just small companies, that's a whole lot of innovations and different companies coming together. And looking, for example, at wind offshore, which is extremely important for the North Sea region, there is really massive investment in that. You see now well underpinned trajectories that can bring down the cost of wind offshore, where they are today, with about 50%. But it will take another 10 to 15 years. And if you see what is needed to do that, that needs stability. You must have the time and space, for example, for an offshore sector to develop new ships for more efficient maintenance. It's partly in improved designs of the rotors. It's in economies of scale. It's in scale also of linking the different parks together and the entire infrastructure. So that is a whole set of conditions of which young entrepreneurs and new business is part, but not the only thing. So at the moment you want that entire sector, that innovation system to thrive, you really need a public-private partnership. Mm-hmm. So it is about indeed de-risking in that sense, that the industry can also trust a government or a set of governments or European Commission for that matter that says that's where we want to go. It will take us 10 to 15 years. It will not be competitive to the fossil reference, but we will back it up. But the target is to let those costs decline and then come to a competitive cost realm. And that's what countries like Denmark, for example, in the wind sector have shown. They really took the time, 10, 15 years, sometimes a few decades. The bioenergy sector in Scandinavia, that is really the model and the patience that you need, the public-private partnership overall, to get a fully competitive sector going. Mm. And so it is entrepreneurship is a very important component of that, but it is part of a far larger strategy.
I see. Thank you. Back to Anup, who gets the challenging questions. So we've heard about a couple ways you can de-risk technologies and work with companies. And I know that when you're looking at later stage investments, there's a whole way in which you can evaluate companies and technologies. With universities, the ideas coming out of the labs that could potentially be disruptive and breakthrough, what is your view as a venture capitalist about the ability to sufficiently de-risk these technologies and get them to the point where the venture capital, at least the mainstream, quote, mainstream venture capitalists would be very keen on investing in these companies? How do you go across the, quote, valley of death? Is that, what is the way to do that, in your perspective?
I'll answer that question. Bill Clinton was very good at answering only the questions he wanted to answer. So I'll try a little Bill Clinton move on you and see if you notice. So I think the way to get the attention is to look at, what are investors interested in today? And there's three things that people are interested in. One is how to solve the issues around food security. The second is how to think about water scarcity. And the third is how to think about energy access. And that's where I think folks are moving towards. And then once you're thinking about those areas, teaming up with capital becomes, kind of not easier, but it becomes, the door is open. The second part about this is, people are always asking me about how are you thinking about commodity prices in this marketplace, and how are you thinking about oil in this marketplace? And our view fundamentally is that, you know, price is not the enemy, volatility is the enemy. If you told me the forward curve for oil, whether that's at $10 or $30 or at $100, I can build a business plan around that. Same is true for aluminum, the same is true for silicon, et cetera. What I can't deal with is volatility in the marketplace. So I think that the second area is thinking about, again, you know, if you're not able to de-risk volatility, how are you thinking about volatility in a marketplace which is changing with a bunch of externalities? The third, and kind of this question of how to bridge the valley is get to cash flow break even as soon as possible. Come with us with a fully funded business plan. You know, the ability for us to continue to fund into negative cash flow businesses is just painful. I mean, we are looking at a business today that has had over $1 billion of capital invested into it, but is still not profitable. And, you know, they're coming to us and asking us to put in our next round of capital and saying, we are the last capital in. So credibility becomes a question in that type of case. You know, I think that both on the debt and equity side. So come to us with a fully funded business plan or a path to profitability that seems believable, and prove that out. And what that naturally tends you to is capital-light business models. So what's being funded today are capital-light business models which don't require you to build a $1 billion factory or a $1 billion R&D budget in order for you to get profitable. And that's where capital flows are going in today.
And so as a follow-on to that, in these capital-intensive investments, do you think that there is a strong need then for public support to bring some of these forward? Will it be the case that most likely the venture capital industry today is not going to be strongly investing in these capital-intensive, very high-risk kind of entities and going more for the capital-light model?
You know, the guys that try to bridge that gap, and I think the right capital source is what you saw with the yield codes in the warehouse facilities around solar. And here, fundamentally, if you have on one side an interesting technology and on the other side you have an interesting offtake agreement, in the middle, that valley of death gets built out by folks that aren't venture capitalists. Venture capitalists are terrible investors because we all want short-term views on a long-term problem. We don't have enough capital to last through the billion-dollar cycle. So the guys that have the ability to do that are fundamentally debt and quasi-debt guys. And I think that what I was talking about earlier, where the IPP model got built out because of the fundamental belief in the offtake, is what gets done here. So I think that the debt and quasi-debt kind of mezzanine markets is where that'll grow into. There's a lot of funds that are going around this. You know, so, you know, to level set here, you know, we talked about kind of overall the industry got a 7% IRR over the past 25 years. You know, if you look at the way that we kind of do risk reward, from a VC investment standpoint, you're looking at somewhere between a net 20 to 30% IRR in a 3 to 5 year period. On a private equity perspective and mezzanine, you're looking at somewhere between a 10 to 20% investment, but over a 10 or 15 year period. So you're much more multiple driven. And then the debt guys are looking at kind of between 0 to 10% returns, depending on the geography. So I think that instead of looking at the VC space for bridging the valley of death, where I think it's too short term, not enough capital, too high return expectations, you need to shift downstream and look at the mezzanine market and the debt markets, but you have to be able to de-risk it in order to attract that capital.
Thank you. And so I come back to John. You are in the midst of de-risking with your FO technology in the water space. So what are the challenges going forward now that you're seeing in your business that you're at this point where it's time to take that next step from what you've been able to demonstrate so far?
Well, let me go back, wind the clock back. For me, there's 4 challenges. And it started with the very first prototype we built, and the first challenge was access. So we loaded it in the back of a pickup truck and we drove down to the beach and we thought we'd be able to desalinate. And then I learned that we needed permits, and then I realized in California it's going to take me 8 years to get a pilot permit. And so I saw a little ad in the newspaper about Mazar running a competition. And I ended up having to come all the way to the UAE to get access to seawater. That's a long way to go, and that cost me a lot of money. Okay, that was the first challenge. But the second one then is, the minute I got here, it was, well, how do we know your technology scales? We don't want a little pilot, we want a big pilot. And, you know, as a little company, you need money. Fortunately, again, Mazar stepped in and said, okay, we'll help you fund the pilot. We're in the third phase of this, which is now, okay, you've bought the big pilot and you've got access to the sea, how do we know it's reliable? And so the only way to answer that question is to sit and wait and keep it running, and that takes funding, which is the last bridge of the chasm I got across, which is now I need to find enough funding to get this thing to run all the way home. And then once I think we're there, a number of people will step forward, and I think it's this mezzanine round of financing. We'll get project financed, and we'll be able to find, we're going to have to change the business model from this mindset of having to build equipment ever bigger, which I think is a problem for startups. We have to maybe start looking at licenses, things like that, change the business model where it isn't so capital intensive for a while perhaps. So perhaps get partners that will license and build products and for you, and at some point you'll be able to take over and become partners in an IWPP or IPP project. But in the beginning, the capital required is just too high for, I think, for most people to stomach.
In your business, given that as you said, you had to come out this far in order to find water to try and desalinate to prove your technology, do you see that given the competition and the challenges in taking a technology to scale, that the play for these more capital-intensive, we'll say, technologies to be regionally focused initially, try and look at your different markets, find a place to initially try to demonstrate and show that you can attack that market and then go global, or is it one shot that can go all in these type of technologies? Clearly today, if you've got the next social media company, you're global from day one. So in these capital-intensive technologies, what is your perspective on a strategy for globalizing?
Well, it's not a day that doesn't go by that my board of directors doesn't tell me to focus. So we can't go global. We don't have the money. We don't have the headcount. We don't have the engineers to support trials. So typically we stay away from large municipal plays like seawater desalination. You could ask the question, why am I here then? But so the focus has really been to go after industry, because in industry, the decision is quick. The CFO makes the decision because he wants to save water, and there's a payback period. So our focus has been industrial desalination and try and limit the number of customers you work with. But you know, Mazar entered the picture and gave us an opportunity which I couldn't pass up. So while we are doing a seawater desal, for example, we really have to focus on near-term revenue, which is a lot more industrial. So you go after a narrow segment first before you branch out, because the municipalities will take a long time to get you approved. I mean, we'll probably go through a 5-year approval cycle in most places in the Gulf.
It's very interesting. And so, you know, I think I'm going to come to Andre now, because John raises some very interesting questions about these capital-intensive technologies. And I know, Andre, you were talking about some within your sphere of thinking about taking technologies forward that are capital-intensive. You're talking about wind technologies and, you know, these types of things. How do you incentivize or attract potential entrepreneurs to take that leap and actually get involved in trying to work with you to commercialize their ideas and when they're capital intensive like this? You find that's something it's hard to do, or in Europe, in your context, is that happening in a fairly robust, regular way?
I think that zooms out a little bit to what are really the policies in the European countries and what's driven by the policy frameworks of the European Commission. And really talking about de-risking and creating these markets for these new technologies is about government policies at the end of the day. Like overall, if you look at the major learning curves that we have observed, fortunately, this can be in solar, this can be in wind, this can be in bioenergy technologies, energy efficiency, etc. They all follow the same rules. You're talking about pathways of 10, 20 years. It is about new industry, new infrastructure that has to gradually decline its cost. And there is all kind of entrepreneurship investments in there in which you're down to a business model and venture capital, etc. But the overall pathway needs to be backed up by rock solid government policies. And you really see a clear distinction between countries and then industries in those countries that are successful in that. And that is generally the key factor is a public-private partnership. You really have a concrete between government and industry that gets that going. Countries that have feeble policies, like the Netherlands is an example in that sense, are much less successful in building these new sectors. So it is really, you need a long-term view if it is about building new infrastructure, building new industry that can actually compete in the market and compete with a fossil reference. That's really what you're fighting, and that needs to be backed up by public policy. That's an absolutely critical factor.
No, so public policy, I mean, that would be a key issue, but then I'll come to maybe a NUP. And I know, say you're a venture capitalist and you're looking at these companies coming in and they're saying, look, you know, I can get a very good return because there's a policy in place that's going to have an offtake for my power production or what have you at a very good price. Do you, as a venture capitalist, or the industry in general, see these policies and feed-in tariffs and, you know, renewable energy mandates of different forms? Do you see that as something that would attract capital into these companies, or do you see that as being too risky, that government policy may not be sufficiently stable over the time of your investment?
You know, it's tough because the history here is hopefully not indicative of the future again, but the history here is that there have been government policies that have spurred innovation, that have spurred capital flows, but then it goes away. And it's things like the Renewable Portfolio Standard or the Production Tax Credit, where you have, you can almost look at a graph which shows what is the production tax credit for wind, for example, and when it goes away, investment goes to zero. And then when it comes back, investment goes back up. And there is a corollary around solar. You know, the Renewable Portfolio Standard, it pushed a lot of renewables into the marketplace, created a mechanism for support around that. The area that I think that we've all been waiting for and kind of the overhang is around whether there's a carbon tax or not, and what exactly is going to be happening in terms of putting dollars into this market. You know, the market around carbon pricing historically has not been great. There's been huge volatility in that in the past. So what investors have learned is don't rely on it. But I don't think that that's actually the right answer. I think that the right answer is create stability because you have this gap in financing that exists, because there's a role for government, create stability over a long-term policy and move forward in that. I haven't found a good example of that, so you know, if anybody in the audience has seen a good example of something that could work out, I think that this Breakthrough Energy Coalition, for example, I think will, and what's happened at COP will push through some interesting initiatives around creating long-term sustainable solutions to bring government capital and government policies to create a stable regime underneath which we can underwrite. And fundamentally, that's the risk that I'm taking, is what is it that I'm willing to underwrite to? My investment is going to be a 10 or 20-year long investment. I need to know that X, Y, and Z is stable. I don't care whether the price of oil is $10, $30, $50, or $100, but what I can't have is 10 one day, then 100 the next day, then 50 the next day. Volatility is what destroys investments, not price.
It's very interesting. So it's a great perspective to see how, from your investment views, the public policy starts to have a different insight than what you might have otherwise if you're from the Energy Academy thinking about this is a very good thing for us and we can stimulate innovators and entrepreneurs to come forward because of policy. We're looking at the time now. We have about 2 minutes, and so we will start to wrap up because, as I said in the initial part of the opening, that we are now going to transition over, as I do the wrap, into a next set of dialogue with Professor Dr. Suji Nakamura. And so before we go into that discussion, I introduced that discussion with him. I'd just like to summarize a bit. As we start off by saying it's very important to understand how we're going to go to a sustainable energy future and meet these global ambitions by seeing how the partnerships go across the innovation life cycle, starting from academia and then going forward into attracting venture capital investment when ideas start to have that prototype or proved out concept flavor, and then going forward further to become full companies. I thought it was very interesting that certainly starting in the academic realm, the faculties see the opportunity to work with companies, and sometimes it takes a little bit of matchmaking to see that the pure quest for knowledge, which gets faculty promoted, needs to be bridged over so that small companies, as in the case of Trevi Systems, can succeed in the partnership. And so this Mazar Institute partnership John talked about was very successful, and some of the things that Linda talked about how she sees working with industry were good ideas about how to get faculty to be incentivized to work productively. And then, of course, Alejandro's model with the SBRC is very different from the pure academic. We have a consortium in which industrial partners have come together to overcome a very challenging issue in sustainable aviation jet fuel within a context which is unique for this region, this integrated seawater energy agricultural system. Andre is a very different structure. I mean, I think the Energy Academy Europe is great. I wish you luck on that because it is a novel, unique way to span that bridge, or span that entire spectrum of going from the educational component into trying to bring these technologies, especially if they're going to be companies, through and forward that there's challenging times. And then Anup, of course, we thank you for your perspectives. The challenging questions came to the guy who has to figure out how to make it all funded, right? So people want money and they come to you and you have to tell them no. So, what's in your mind about always having to give those kind of answers and how do they get that funding eventually? So we appreciate the time of the panelists today. It was a great discussion. Thank you for that. And so what we're going to do next is a very, I think a very important discussion with Dr. Suji Nakamura, who, as I said previously in the early part of the opening, is the 2014 Nobel Prize winner in physics for his co-invention of the blue light-emitting diode, an extremely important invention. And what this demonstrates as we get into discussion, and what took him forward even in the 2015 Global Energy Prize for the white LED, which obviously builds off the blue, is that science takes a long time to commercialize in this clean energy space. In particular, Dr. Nakamura is going to tell you about the importance of his invention. It took how many decades, as you'll tell us, to get to the point where this became something that was recognized and has achieved that commercial traction, which is now, I believe, probably, if not the most, one of the most important sustainable technologies we have on the market. And it's really making an enormous global impact. So we're very looking forward to his comments. So I'll ask the rest of the panelists, thank you very much. I appreciate it. We'll give them a round of applause.